All right, now we're getting into section 6.2, and now we're going to be simplifying rational expressions. All right, so what are rational expressions? Rational expressions, they're fractions that have algebraic expressions in their numerator and or denominator. And algebraic expressions are just variables, x's, y's, x plus 2, anything that has a variable in it is an algebraic expression. But no equal sign. We're not going to have equal signs because they're just expressions. So here are your main reminders for simplifying algebraic expressions. You can only cancel factors. I'm going to make that capital. Remember, factors are separated by multiplication. I'm going to say this over and over and over again, and you're going to be sick of me saying separated by multiplication or factors, because those are the only things you can cancel. You cannot cancel terms. Remember, terms are separated by plus or minus. So if you have things separated by plus or minus, those do not cancel. The only things that cancel are factors, which are separated by multiplication. All right, our first step is always going to be to factor. So our factoring skills, remember when we learned factoring, I said we're going to be needing this all year. Our factoring skills are going to be coming a lot in this chapter. The denominator can never equal 0. Remember, your denominator can never equal 0 because it would be undefined. So therefore, we must restrict the denominator restrict the variable for rational expressions. All right, so we'll come back to these always. These are kind of our steps and reminders. But since factoring is such a huge part, remember some factoring reminders. Always look for a GCF first. And again, this kind of goes along with that flow chart. You still have the factoring flow chart. That would come in handy. If you have two terms, you can use difference of squares. Remember, difference of squares is where you have a perfect square minus another perfect square. And that becomes, you take two sets of parentheses, you take the square root of the first term and put it in the front of each set of parentheses, square root of the second term, put it in the second term of each set of parentheses, and you have one positive sign and one negative sign. If you have three terms with the coefficient of x squared equal to 1, then remember that's our SAM factoring. And if you have three terms with the coefficient of x squared greater than 1, that's when we're going to do slide divide bottoms up. All right, so here are some examples as we simplify rational expressions. And we state any restrictions on the variable. We'll talk about that coming up. So this is, number one is really kind of the simplest form. We actually did problems like this when we did law of exponents. And what's really going on here is you don't have to write this step, but we really have multiplication between everything here. So I have 4 times x to the 7th times y, and it's 8 times x squared times y cubed. So what that means is that this is already factored. So I can cancel or simplify any like factors. So I really have like 3 factors that I'm going to be looking to simplify: the numbers, the x's, and then the y's. So 4 over 8, that's a regular fraction. I can reduce that to 1/2. X to the 7th over x squared, that's our law of exponents where I subtract exponents. So I have x to the 5th up top. And then I have y to the 1st over y to the 3rd. I subtract 3 minus 1, which is 2, and there's more y's on the bottom. So I'd have y to the 2nd on the bottom. Now, what's the new part? This new part that says we have to restrict the variables. Remember, the denominator can never equal 0. So in this particular problem, I have 2 variables in the denominator, an x and a y. And basically we're saying, all right, what numbers would go into the x that would make the whole denominator 0? Well, if x was 0, 0 squared is 0, and then that would make the whole denominator 0. So what we have to say is x cannot equal 0, because if it did, we'd have a undefined expression because we'd have 0 in the denominator. Also, the same with y. If I plugged a 0 in for y, 0 cubed is 0, and that would make the whole denominator 0. So for right now, since these x's and y's are just being squared and cubed, we're just saying x and y cannot equal 0. Eventually, the x and y won't be able to equal other numbers, as we see coming up. Okay, so this problem again was pretty much like law of exponents we did in the beginning of the year. The only addition, we restricted the variables in this case. Now for number 2, remember, we can only cancel, right here, we can only cancel factors that are separated by multiplication. We cannot cancel terms. So the way we're looking at right here for number 2, a lot of people are going to want to cancel the x squareds, but these are not factors. These are terms. They're separated by subtraction. So we cannot cancel anything out the way it is right now. So we go back here and we're saying, all right, our first step is to factor. We have to factor this problem before we can cancel anything out. So I have no GCF, because that's what we always look for first. There's 3 terms with a 1 in front, so it's Sam factoring both the top and the bottom. So x and x, what multiplies to -6 and adds to -1 is 3 and 2, -3, +2. And then the bottom, x and x, what multiplies to 6 and adds to -5. So that would be -6. Oh, never mind. I made a mistake there. That would be -3 and -2. All right, now that we are separated by multiplication here, now is the time where I can cancel any like factors, anything in the parentheses that are exactly the same, I can cancel out. So I have an x minus 3 factor here. I have an x minus 3 factor here. Those would cancel. I have an x plus 2 and an x minus 2. So even though these both have x's and both have 2's, they're not exactly the same because one's positive and one's negative. So I cannot cancel those factors out. So what I'm left with here is x plus 2 divided by x minus 2. That's my simplified expression. And then now I go back. And again, we have to restrict the variable. So basically, again, what we're saying is anytime this denominator equals 0, the whole denominator, anytime the denominator is 0, that'll be undefined. So what we're going to do is we are going to, and you might want to write this down, the way we can do this is to set each denominator factor equal to 0 and solve. And those are going to be the variables that cannot work. Those are going to be the variables that you restrict. We did that here. X was a factor. We said x squared was a factor. We said equals 0. Y cubed was a factor. We said equals 0. Now, you can do this off to the side. X minus 3 is a factor. So if I set that equal to 0 and solve, I would get x equals 3. So what I'm going to say here is x cannot equal 3, because if I plug 3 in here, 3 minus 3 is 0, and 0 times anything is 0. So even though this wasn't a factor in our final answer, it was a problem. It was a factor in our original problem, which would make it equal to 0. So I'm going to say x cannot equal 3, and then I have to set the other denominator factor equals 0, which was x minus 2, which I'm going to say that would be x equals 2. So then I would say x cannot equal positive 2 either, because again, if I plug 2 in here, 2 minus 2 is 0, then the whole denominator becomes 0, and we're undefined. So my final answer, x plus 2 divided by x minus 2, and then x cannot equal 3 or 2. Again, because if I plugged either one of those in for my x's, I would get a 0 in the denominator, which is undefined. All right, for number 3, this is already factored. It's already separated by multiplication. And the first thing you're probably going to see is that, oh, great, 2x plus 5, 2x plus 5. What you also might notice at first is that this looks close, but not exactly the same. So I have 2 minus x and x minus 2. So they're close, but not quite. You always want your x to be positive, like we've been saying all year. We always want x to be positive. So what I'm going to do, if I had this x minus, or 2 minus x, I always want the x to be positive. So what I'm going to do is factor out a -1 as my GCF. So if I factor out a -1 and divide everything by -1, I would get a negative divided by negative is positive. So I have positive x and then -2. So this top, the 2 minus x, factors to this. -1 is my GCF times x minus 2. And all I did was I took this factored out GCF of -1 because I want my x to be a +1 in front, or a positive number at least. And now I have x minus 2, and I still have the x minus 9. Ooh, and look what we have here. An x minus 2 and an x minus 2 factor. We still have those cancel. And so I'm left with a -1 on top and an x minus 9 on the bottom. Again, we had 3 factors in our denominators to start, so I would set each of those equal to 0 to see what restrictions I need. And again, eventually you can probably just do this in your head, the restrictions, but I'm just showing you. So if I would here, I'd have to add 2. So it'd say x cannot equal 2. So x cannot equal 2. Because if I plug that in, 2 minus 2 is 0. I would subtract 5 and then divide by 2. So x can equal -5/2. Because 2 times -5/2 is -5 plus 5 is 0. And then I would add 9. X cannot equal 9. Because 9 minus 9 is 0. So this is my final answer. Alright, you are trying the homework then. Oh, here's some other examples, sorry. Some other examples are on the back for you. This just shows us that when we cancel things out, they are equal to 1, which is why they can cancel, and 1 times anything is anything. These are examples of things that cannot be simplified. Again, if it's separated by addition, they can't be simplified. So here the 6's can't cancel because this is a plus sign. They're not factors. Again, the x cubes cannot cancel because this is separated by plus sign. They're not factors. You can only cancel factors. Same thing here. I can't cancel my x's because the whole factor here is x plus 2, and this is just a factor of x. They're not the same. Okay. The other thing, like we just went over, is that sometimes if they look similar, like -2 divided by 2 is -1. Okay, so if they look similar, you can cancel them, just make sure they reduce to -1. This is the big one right here, where if it's something like, if you ever have a -x, always pull out a GCF. So if I pull out a -1 as my GCF, all of a sudden I have x plus 2 over x plus 2, which then would just reduce to -1. Same thing here. I have that -x, so if I pull out a -1 as my GCF, I'm left with x minus 5, and that's what I had on the bottom. So that's the biggest thing, is always make sure your x is positive. And then you do have 2 other examples here as needed. This is one like our first one we just did, and then here is another one where we'd have to factor. All right, good luck.